Now we have learned that acids are proton donors. When they are dissolved in water, they will donate protons to water. Well, depends on how many protons each molecule of the acid can donate. An acid can be classified as a mono, di, triprotic acids. A monoprotic acid is an acid that provides only one proton per molecule in an acid-base reaction. So this is a generic representation of a monoprotic acid. Ha represents an acid. One proton is donated to water when it is dissolved in water. We have been writing this for several times. This equilibrium is called acid ionization equilibrium. This is the acid ionization equilibrium of a monoprotic acid. Examples, okay, we have hydrochloric acid, nitric acid. Those are the acids we have talked about before. They are both monoprotic acids. Diprotic acid, an acid that can donate 2 protons per molecule during an acid-base reaction. The 2 protons are not donated all at once. They are donated in a stepwise manner, one at a time. So this is a generic representation of a diprotic acid ionization in water. The acid first transfers a proton to water. Water becomes hydronium ion. The acid becomes its conjugate base. However, this conjugate base is amphiprotic. It still has a proton in it. Then this conjugate base of the diprotic acid can continue to function as an acid to react with the water molecule to donate another proton to the water molecule. So Ha minus, after donating another proton, becomes A2 minus, missing a proton now. The proton, where did it go? It went to the water molecule. Water becomes hydronium ion again. All right, again, this is the generic stepwise ionization process for a diprotic acid. We are going to practice this stepwise deionization process for a diprotic acid, for carbonic acid. So in light of this, we're going to write out the 2 steps for carbonic acid. All right, so we start from beginning. Carbonic acid in water. All right, a proton will be transferred from the carbonic acid to water. Well, you're going to produce hydronium ion. Water accepting a proton becomes hydronium ion. Carbonic acid, after donating a proton, becomes its conjugate base. We know how to write this conjugate base. 1 less hydrogen, 1 less positive charge. So 1 less hydrogen, it becomes HCO3. Right now, H2CO3 is neutral. After losing a positive charge, it is going to carry a negative charge. I hope you realize the pattern here. That's what it is. All right, then H, which is bicarbonate ion, the bicarbonate ion still has a proton that can be donated to water. It can donate a proton again to water molecule. Again, water accepting a proton becomes hydronium ion. Itself becomes carbonate ion. I hope again you see it here. make sure you know how to write this by yourself. Here we go. That's what it is. We'll move on. Triprotic acid. Once we understand the concept of monoprotic acid, diprotic acid, we understand triprotic acid, an acid that can donate 3 protons in the acid-base reaction. The 3 protons again will be donated in a stepwise manner. So if someone asks you to write out the stepwise ionization process for triprotic acid, you'll know there should be 3 steps. Here we go. This is a generic representation of the ionization process for triprotic acid. 3 steps, 1 proton at a time. Here we go. Let's practice the stepwise ionization process for the triprotic acid, phosphoric acid. I started it for you. Pause the video, complete the whole process. There should be 3 equilibriums, 3 steps. Once you're done, unpause the video to check the answer key. Polyprotic acid, well, if an acid can supply 2 or more protons in the acid-base reaction, then it is classified as a polyprotic acid. Both diprotic acid and triprotic acid are polyprotic acids.